This is NSAA 2021, Section 1, Question 51. So in this question, we have a mixture of 4 amino acids, which has been spotted onto a chromatography paper. The bottom of the paper was placed in solvent 1, the paper was then dried, turned 90 degrees and placed in solvent 2. And each of the amino acids were identified with their RF values. So here's our piece of paper. Our first solvent goes from the bottom to the top there, and our second one goes across the sides. And all these spots show our different amino acids. We have a few statements, we need to work out which ones are correct. So let's start with our first one. Leucine travels further relevant to the solvent front in solvent 2 than in solvent 1. So we just need to work out how far our spot has moved relative to the total solvent moving in 2 and in 1. So for this we can use this little equation here, the distance the spot moved divided by the distance the solvent moved. So let's draw on some lines here so we can figure out how much our leucine spot has moved. So for solvent 2, it has moved 14 centimetres compared to the total 20 that the solvent moved, which is equivalent to 7/10. For our solvent 1, we can see that it's moved 8 centimetres compared to 10 overall. So we've got 7/10 and 8/10. And we can see that in solvent 1, the leucine has actually travelled further relative to the solvent. Therefore, this statement is incorrect. Our second statement is that lysine has a greater RF value in solvent 1 than in solvent 2. So how do we calculate RF values? Well, that's just something we've done before. The distance the spot has moved divided by the distance the solvent front has moved. So let's find the RF values of lysine. So again, drawing our little lines on to see how far things have moved. In solvent 1, it's moved 6 centimetres compared to our 10, and in solvent 2, it has moved 8 compared to our 20, or 4/10. So we can see that in solvent 1, our RF value is greater. So this is correct, and our answer is B. But let's look at the other statements to see why they are incorrect. Statement C says that solvent 1 alone could be used to separate all 4 amino acids. So is that true? If we just had solvent front 1, would this be enough to separate all of our amino acids? Well, we can see that without our separation of our solvent front 2, these would all be on the same line. If this was just a one-dimensional graph, these two spots, as they have the same y value, would just be together. They wouldn't have spread out because of solvent 2. So this is incorrect. We couldn't just use solvent 1 to separate all 4. Statement D is very similar. Solvent 2 alone could be used to separate all 4 amino acids. Well, in the same way as solvent 1 alone couldn't be used, solvent 2 could not be used by itself because, for example, these two would not be separated out by solvent 1. Because they're on the same x-axis, these would just be a spot together. So we could not just use solvent 2, we have to use them in combination. Our final statement is that the RF value of tyrosine is 0.6 in solvent 1 and 0.7 in solvent 2. So if we use our equation for RF, let's calculate it for tyrosine in 1 and 2. So for 1, we can see it's moved 6 centimetres relative to the 10, or 0.6, so that's correct. And in solvent 2, we can see it's moved 6 in 20, 3 out of 10, so that's 0.3, which is not 0.7. So that's incorrect. We can go back to our final answer of B.